people to another example video for SOuP. In this one I'd like to talk about the solver node. It's been in the SOuP arsenal for a wee bit now, but I haven't had time or the opportunity to really take a good look at it and get my head around how it actually works, but now I do. So if we take a look at some of the scene examples that I've been working on the last couple of days, we get some pretty neat effects going on, lots of extrusions and curly things happening. What else do we have here? We have things like this. Okay, if I go and bring up my node editor, and let's have a look at the extrude face. Bring down the scale a little bit on these things, maybe increase the extrusion on it. Let's get some quite neat looking tumbleweed happening. Let's have a look at another example. This one here. Okay, so these are slowly getting more advanced examples, but you can see we're getting some neat animations happening, and it could also be used as a modeling tool as well as animations. Before we move forward, I just want to show you one more. Bring up the node editor, and I just having trouble with this colour, so I'll turn it back to the colour it should be, and push play. And you can see I've just got these raindrops falling on the ground, and where they collide, we're having the solver node move into action and create these little curly growths coming out of the ground. So that's just weight transference from the particles onto the plane, and then the weight's being used as a component selection. So that one's slightly more advanced than the rest of them, so I won't start off with that one first. I'll just start off with something simple, and probably just go new, and maybe I'll just use a platonic solid like so. Okay, I select it, I just freeze transformations. It's not going to let me do it. Don't know why, sometimes it lets me do it, sometimes it doesn't matter. So from here, what we do is you select the mesh, and then you go into the SOuP menu and you go solver, and Maya will connect the solver up for you to the input and the output mesh type. And as you see over here, we've got the end times connected to the scene time node for animation, and we've got a start frame and end frame, which is just taken from your timeline. And we've got a step, so it's how many steps it takes per frame, or how many frames it steps through. And we've got cache here. And of course, if we want it to extend past 120, we can just make sure that we adjust that value here as well. So to kick it off, we're just going to do some fancy extrusions. So how we work this is we will start off with a group node. Now I'm just going to show you what doesn't work, and then after explaining that, I'm going to show you what does work. So we'll need a group node, and then we'll get an extrude node. So extrude face, And essentially we're just creating a little loop in the solver node here. So if we take our mesh out geometry in geometry, and let's say we want to use face components and work in the range, so hopefully you know a little bit about the group node, and that means every second face, we're selecting every second face, and we want to extrude that. So we want to reconnect it up like we normally would and put components in geometry, and then from there create a little extrusion, and then we feed that back into the solver node, and that goes into the insolve. We can't stick it in the geometry because the polyplatonic is already input in there, so we just go straight into the insolve. And every frame it loops through this and outputs our result into our platonic shape mesh. So if I push play, we get our first extrusion. First frame, one extrusion. If I push it again, we get a second extrusion. If I keep going, we end up something like this, which is kind of not what we want. It's a bit of a mess. Okay, so maybe we've got too many faces there, so we try that. And we kind of end up with something a little bit nicer to look at, but still not quite what we want. We take off, in the poly extrude face, we can take off, keep faces together. And this creates a even more interesting looking object for us. But after a while, even though it's an interesting looking shape, it does start to bog down our system, and we're only just under a second, so 1 second, and we're just about pretty much at our limit, so maybe we bring that up to 20 instead. Push play. So we get a certain kind of effect there. It looks nice. Not too bad. But there is a better way of doing this, and that is that we're able to control the faces that we want to extrude, and normally it's the same face over again, so we get these tentacle looking things that come out. So the way that we do that is that we use a double group node combination, and I'll explain this more in the next tutorial, so I'm just going to gloss over it for now. But essentially, you use the first group node. You want the output from the mesh that hasn't had any operations added to it, so the original mesh, for example, goes into there, and we want to make sure the faces are selected, and we can stick to the range, is fine. Let's just bring that down to 10. And for the second group node, we want the resulting mesh to compare it with. So the original mesh goes in there, and the result mesh comes into the second one. Then we combine those two group nodes together through the components. We can't go through the geometry because he's already put in there, so we use components. And then we basically just say, oh, we on the second group node, we just want to say we want the intersection of our component selections between the two group nodes, and we make sure that that's face there. We want, in the second group node, we want all our faces as part of the output solver, so we just type in an asterisk in there, and that'll select all our faces for us coming out of here. All our faces, or actually our range faces, are coming out of there. We can select all if we want to. In this case, I'm just going to use range. And then we use the intersection in the input components. We want the intersection of the two, and then we pipe that selection into our extrude, like so. And now when we push play, we get this. Now we're kind of feeling like we're getting somewhere. So we can bring the local scale down on the extrude node, and then we start getting this. And maybe we want more faces extruded, so let's bring our range up a bit. So now we've got more. Let's try 2. Go back into the poly extrude. Let's add some randomness to it. Now we start getting this. Okay, so let's really bump this up. I like all extrusion. Like this now. Even more. Okay, now it's really going fast. Because per each frame we're extruding it by 1.4 units. Each frame, we can reduce the speed rate by increasing the step range. So now it's going to evaluate every 10 frames. It's dead. But we're going to bring that down to 1. And then reduce our extrusion rate, like so. Okay. So from here, we can try something else. We can extrude the result mesh that comes out of the solver. So good practice, as in good SOuP practice, we create another group node and we just feed the result into there, into the geometry, and we want to select every single face. So this just gives us control of the output mesh. So we might want to change it to range and just have a range. And then we just go extrude face again. And you can use any mesh operation node that you like. I'm just quite partial to using the extrude node. And then of course you just connect the components and the geometry up there. And then we do the same input mesh there. Add some extrusion. Get rid of keep faces together. Now when we output, we're getting this kind of thing happening. Maybe we want some more there. Maybe we want it to go thinner. Right, it's not working. Okay, that's fine. And then we end up with something like this. Okay, turn off the wireframe shaded. Let's say we want some more extrusion on there. Okay, let's put a different shader on there. Let's go for a, is it a ramp shader? Yeah, ramp shader. And let's say facing angle. And put a whole lot of colours in there. So and now we get something quite special happening. Okay, so that's that one. The next one I wanted to show was this is using a couple of other SOuP nodes that are quite new to the tool set, the Resample node and the Resolve Point Collisions node and the Solver node. So let's take a look at those. I'm going to start with just a disk, and we can probably reduce the poly count on that down to say let's just go for one subdivision for now. So like before, just go into the SOuP toolset and select Solver, and that'll automatically make the connections for you if you have the disc shape mesh selected. And of course our start and end frame are there for us, and the end time is already connected. So like I said before, we're going to use, instead of the extrude node, we're going to use a new node called the resample node. And essentially the resample node just adds more points to your mesh. So we have a length factor here, and it adds points with, once the length of the edge reaches length of 1, then it starts to subdivide that edge with more verts. And also we're going to need a resolve point collisions node, and this just pushes the verts away from each other so they don't go through one another. So we're going to hook that up, our geometry, straight into the point collisions, and then I think we can just go straight into the SOuP, and we're pretty much good to go. Just push play, and you see we get this pretty neat effect happening. So you can see that we're getting extra verts added here by the resample node, and the resolve point collisions node is pushing the verts away from each other so that they don't collide. So we can keep playing that, and just to add a little bit more interesting shape, we're going to extrude it. So we're just going to create another group node, and this is always good practice, is to just create your group nodes so you've got a sample of points that you can work with. You can change it, the operation, to pattern, range and so forth if you want to in the future. And so we're going to get an extrude net here, body face, so we're going to select all the faces, so faces select pattern, we're going to put an asterisk in there, and then we're going to connect our components and our geometry, and we're just going to do a small extrude on that. Let's just say 1, and feed that into the mesh, and then you see we're getting some extrusion. Okay, let's hide our wireframe node. Okay, and just for even more fun, let's just smooth that. Pretty smooth. Oh, I think the poly smooth face is the one that I want. And again, I'm going to create another group node because it's just how I do it. And just select all. Connect those outputs into each other. Okay. And I think here we just want it on linear. Yeah, there we go. So we get something pretty funky happening with the mesh if the method's on exponential, so just switch that to linear. Stick our wireframe on so we can increase the divisions. Of course, the calculations are going to take longer to show up, so we're just going to drop that back down to 1 again. Just wanted to show you, and then you can just push play, and there we get that kind of thing happening. And of course, we're going to extrude there. We can change it to range, and then you get this happening. Okay, let's just take the smooth off just to help with the speed a bit. So you can just see that you know, now we've got a little bit of control if we want to have some artistic control over what we're doing. We can change this to something like face perimeter. I don't even know what exactly that's doing. But, so back to pattern. And there you have it. So that's using the resample and resolve point collisions. Okay, so I'm going to now show you a 3D version of the same thing. So I'm just going to keep my network a little bit here. Probably just get rid of the extrude, and I'm just going to create a 3D object. So I'm just going to do a platonic solid, and that's pretty good. It's minimal sub-Ds on it, so we don't need the mesh because we've already got one, so we'll delete that, and we can throw this into the solver and geometry. The solver can go into the geometry and geometry there. So now we have a 3D object. Okay, we're just going to turn our poly smooth off for now, and if I push play, we get this kind of thing happening. Starts off nice, and then our object gets more verts from the resample, and then it just starts to look a bit messy and not very nice at all. So to fix that, basically what's happening is we don't have enough subdivision inside our mesh, so we're just going to throw in a SOuP remesh node, and that's going to help us with adding more tessellation to our object. So I'm going to change this to typology, and down here I've got typology where you can play with the edge length and preserve detail. So just add that to the end of the resolve point collisions, and then replace the geometry with that one. So now we have a subdivided 3D object, and now we start getting something a little bit more usable. Sorry, I made a mistake there. That should go in geometry and our remesh. So now our remesh goes into the insolve, and we're just going to hit play again, and now we get something that's a little more usable and interesting shape. And if we want to, we can put our poly smooth on, give that a few seconds to crunch, just so we get some nice soft edges. And that's it. That's what I wanted to show you in this lesson. Just the resample node, the resolve point collisions, and when you're working with 3D objects, you can use a remesh that helps build the object for you. And then of course the smooth. And yeah, that's it. I hope you enjoyed that, and like I said, in the next tutorial I'll go into more detail on the group node and its reason to be. Alright, thanks a lot for listening, and I'll see you again next time. Thanks.